All right. So we can go ahead and get started here. You guys, welcome to the third webinar for the IR Innovation Program. So this is a series of webinars that we've created to introduce IR trainees to medical device development. So there's just a couple of introductory slides. My name is, so our speakers for today are Mr. Walter Ryan and Dr. Jake Swan. Mr. Ryan's a Director of Business Development at Cook Medical, and he has been there for, he has extensive experience in the field for about 21 years, and he has multiple honors and awards, including the Endourology Industry Award, and has multiple patents himself in the field of vacuum aspiration and wires and the field of urology. So we're very lucky to have him. He's going to be representing the industry perspective on medical device development. And we have as our other speaker, Dr. Jake Swan, who's an interventional radiologist in Canada. And he has a special interest in technology innovation and development and IT, in addition to biomedical engineering and aerospace medicine. And in addition to technology innovation and IR innovation, he has an interest in systems and analysis. He did his MD at the Memorial University of Newfoundland and his fellowship at the University of British Columbia. So we're very happy to have you both. Thanks for taking the time. The title of today's talk is Bringing New Technology to Life, and this is the industry and physician perspective. Let me go on to the next slide here. I kind of mentioned before, we have a IRIP Research and Education Committee that's involved, or it's made up by medical students who are a very motivated group of students who want to, are passionate about innovation in IR, and they have actually created a survey, and the reason why we're doing these surveys is to get more objective data in terms of how this is helping the IR trainees and stuff. So I know you can't click on this link here, but if you click on the chat box, there's a link that will take you to the survey, and if you don't mind completing that before we get started with the talks and everything, then we'd really appreciate that. The other effort is our Twitter handle, so it's SIR-RFS, and this is one of the ways that we interest in terms of interest in medical device projects and what we're doing, and this is also headed by the med students in the IRIP Research Committee. What we're doing is we're gauging the sort of the buzz around IR innovation in terms of what types of things are attendings talking about, what types of things trainees are talking about, what types of projects are interesting, what problems people are running into. So gauging an overall interest and the unmet clinical need throughout the country. And the next step is going to be ranking that and then forming teams of residents around that, residents, medical students, and fellows around that, pairing them up with mentors in industry, pairing up mentors in the field of, or in attendings in IR, and going forward and tackling these problems one at a time. So please get involved in the Twitter feed there. Just as a quick recap, our first webinar was Introduction to Medical Innovation in IR. The panelists were Dr. R. Pauly, who is the inventor of the Surefire catheter and interventional radiologist, and Dr. Murphy, who won the IR Innovation of the Year award this year at SIR and has multiple patents. So that was just to introduce folks in the field. Our second webinar was by Dr. Srivastava. He's the medical, he's from Medtronic, the business development manager at Medtronic, who spoke about how to proceed beyond the concept, and that was a few weeks ago in May. And so just as a quick recap, what is the driving force behind the IR Innovation Program is that physicians and trainees and medical students want to get involved in the medical device process, and we don't really have a good way to get involved in our home institutions. We may or may not. And so what this paper kind of shows is, it's very important for physicians or folks with the clinical background to be involved with the engineering and the technical folks and the folks with the business expertise and intellectual property expertise, just because it provides that much more of a unique perspective to the medical device development process. You can't do it by yourself, and just an early involvement of all the important fields is highlighted well in this paper. So this is an excerpt from an article that was published by Dr. Murphy a couple years ago that shows the incredible growth of innovation in IR. This is all the patents filed by interventional radiology or SIR members, and there was a huge explosion after the seminal patent for Dr. Palma's balloon expandable stent. And what you see towards the end is that it's kind of falling out of favor, and there's a number of reasons for that we don't really have time to go into, but we want to recreate that and have a grassroots efforts to start that at the RFS. This is from the first paper that I showed, and there's multiple specialties that are involved in medical device development, as they should be, and at the very top is orthopedic surgery. And the reason for that I think is because of this symbiotic relationship they have with industry. It's the AO Foundation, which is a nonprofit, pairing up with Synthes, which is a for-profit organization, and together they train 500,000 orthopedic surgeons every year. And that becomes very important because they have such a good relationship back and forth that there's funded research, funded device development, and just acceleration of the overall innovation timeline for the end goal of improving patient care. So it's a really good model, and something that we would love to follow here with the RFS. This is from an image from the second paper that shows what's really important for people to become good innovators, and what's identified here is that the major innovations are coming out of major technological hubs, which is academic centers, and that's it is not a question of fair or unfair. That's just where most of the resources are. Our effort is to bring that out to the community as well. So people in community programs, not just academic IRs who have their own practice. And so we were really excited that Dr. Swan wanted to be a part of this as well, because it's as far as I understand, and correct me if I'm wrong, Dr. Swan, you have your own practice and you perform in not a traditional sense, academic or university setting, although you may have an affiliation, but it's a primarily a community setting, and that seems to be, from what our previous webinars have raised, seems to be the major sort of hurdle, because you don't have access to the tech transfer office and all that stuff. And so what that paper's conclusion was that there's a key role of large academic IR departments, and key and that's the key enabler of device development, and the key inhibitors are lack of mentorship, industry contacts, and legal advice, and key enablers are mentorship, motivation, and industry contacts. So that's part of the reason for the IRIP as well, to bring all that together for everyone, all the trainees across the country. The way we're doing this is this webinar series, so we're trying to hit all these topics throughout the year. And the second stage is going to be the Twitter analytics that I was talking about before, sort of create an IR skunk works of trainees around the unmet clinical needs specific to IR. And so, it's a fourth pillar of IR, the innovation pillar. So I hope that gives you enough time to fill out the survey, and then what we'll do now is just get started with the presentation here. So, Mr. Ryan, would you like to go first? I can make you a speaker whenever you're ready.
Absolutely, that'd be great. Can you hear me okay?
Yeah, it's coming out it's kind of muffled and soft right now.
Is this better?
Yeah, that's a lot better. So
Okay.
what we'll do is we'll make you a presenter right now, and as soon as you and then we can see your computer now. All right, there we go. It's all set.
Fantastic. Well, thank you for the opportunity to speak with you this evening. I've given a presentation similar to this to residents in the past at a few different societies, and I think there's some helpful information in here, and please feel free to stop me at any time. Little plug for Cook Medical when I get started. Cook Medical is a privately held company, founded in 1963. Grew up in interventional radiology. That is still our largest focus. The 3 business units serving that would be our peripheral intervention, aortic intervention, and IR groups. But grew from the second bedroom of somebody's apartment into a multi-billion-dollar company over the past 50 years, and we really credit that to our physician relationships. And as you pointed out, the physicians understand the clinical need and are in the unique place to really offer solutions. So when I run through this talk, I'm going to cover 5 different I's of product development: inspiration, imagination, innovation, intellectual property, and industry collaboration, which I know is meant to be the prime focus, but I feel like all 5 of these really are tied together and an important part of the talk. So we'll go in depth a little bit on intellectual property. I won't get too carried away. It's something you can spend a lot of time on, but having a basic understanding of it is important if you're going to be an innovator. And then, as I mentioned, we'll focus most of the time on industry collaboration here at the end. So inspiration really may come from anywhere. And this is an image of a product that is used by both our urology and gastroenterology groups. It's a stone extractor. And prior to 1998, stone extractors were made from stainless steel wires, and they always had a little solder ball at the end, and physicians could not understand why we couldn't make a stone extractor that didn't have a tip on it when somebody could make a whisk that didn't have a tip on it. And actually the inspiration and design came from something that many of you might use every day, just making a set of scrambled eggs. So look around you. The environment is a great inspirer, and you never know when an idea might strike. But it's not enough just to imagine a solution to a problem. And going back to that stone extractor, a lot of physicians came to us and said, you know, we want a stone extractor that does not have a tip. We want something that, you know, doesn't cause trauma. We want something that we can open multiple times and close multiple times and it doesn't lose its shape. All those folks were doing for us was really describing a problem. They weren't bringing us a solution, right? So the problem, we understood the problem. Stone basket was not robust enough. In intellectual property terms and in innovation terms, and if you want to have a unique idea, you need to have enablement. So you need to be able to show the how in that statement. So it's not enough to identify the problem, but how do you fix the problem? How do you identify a new material, a new shape, a new approach, a new method that is going to actually allow your idea to work? So that's really a key element to innovation, is understanding the idea of enablement. Here's a shameless plug for my 6-year-old son. I love to get him into my presentations, but especially when I'm speaking to residents, I think there is a misconception that you need to be a very experienced physician in your field to have good ideas. And I would argue that it's actually the opposite, that as a resident, you're uniquely positioned to not be burdened by preconceived notions. You're not already set in your ways. You haven't used this device in this fashion because that's how you trained and that's how you've done it, and I've done it this way for 20 years, and by God, I'm not changing today, right? So watch your attendings, watch your fellows, and see, is there something they're doing that doesn't make sense to you? Maybe there's a clinical problem there. It could be something as simple as ergonomics. Are they standing really funny and you're thinking, man, there's got to be a better way to do this. So the key here is you don't have to be an expert to innovate. I think as a resident, really you have an opportunity to come with a new set of eyes to problems and not be biased. So what are some of the reasons why people get into innovation? And I've worked with a lot of physicians, and including Dr. Murphy, who was one of your first speakers. We commercialized some of his products, actually. And there's a lot of reasons. I think the majority of the time, people are trying to cure a problem. They're trying to further that mission of patient care and come up with a better solution, a faster, easier way to treat their patients and take care of people. Some people are naturally curious, tinkerers. like the engineering aspect of it more so than just the conceptual aspect of it. And then certainly anything worth doing is worth getting paid for. And the revenue as a physician doesn't necessarily all go to you personally. That revenue can help your community, it can help your university. So I know that industry physician collaboration has sort of been frowned upon in recent years and cast as this dirty thing, and there's this payment going on, but it isn't a dirty thing. It's reimbursing somebody for their ideas, their hard work. And as long as it's done in an ethical fashion, it can benefit not only you individually, but your community and your university. So straight up, real easy, kind of intellectual property 101. There are a few things that fall under that umbrella of intellectual property. In medical device innovation, the thing we're most concerned about is patents. Copyright and trademark are things that are going to happen more on an industry side when we write instructions for use or brand a product with a snappy name like N-Circle. And that really does not fall to physician inventors very often, although lots of doctors want to name their products. I will tell you, as a general rule, most companies today won't name something the Johnson retractor anymore. It's something we did a long time ago, but it's fraught with problems. But for the purpose of our talk tonight, we want to understand patents primarily. And what do patents do? Really, a patent does not allow anybody else to replicate your idea for 20 years. So it gives you an opportunity to exclude others for 20 years. And there is a difference between being exclusive and excluding others. But for simplicity's sake, we'll say that it excludes others for 20 years. And in the United States, where I'm assuming most of the people are calling in from, the rules changed about 5 years ago from a first to invent to a first to file, which means now when you have an idea, you need to be very careful about how you protect your idea and share your idea and how quickly you get to the patent office, because in the past, if you had well documented your idea and notarized it and had a date, they would consider that. But now the law has changed and you need to be the first person to file on your idea. And what constitutes a patentable idea? It could be a machine, a device, a process. It has to be novel and has to be not obvious. And I will get into a little bit of the novel and not obvious on the next slide and explain how that works. And as I mentioned prior, you need to show the how. You don't have to go so far as to build a prototype, but you need sufficient data that supports your concept and your theory and shows that it could work. So novelty. You have an idea, and what you want to do, we'll take the stone basket and the whisk idea, is your device different from that in any respect? If it is, then it will qualify as novel. What we're seeing a lot of today, and what we get a lot from physicians, is sort of a combination device and a request for us to maybe make a device a little bit shorter or combine two devices. And people thinking that that is a new idea. And in some cases it may be, but in some cases taking product A and product B and putting them together is not going to pass an obviousness test. And it's going to be really interesting in the industry side of things as more and more of the drug-eluting products come to the market and cell-driven products, whether those combinations with a catheter will withstand obviousness when all the companies start suing each other. So we may have a mutual mass destruction here, and we'll see how the courts rule. But right now, taking peanut butter and putting it with jelly is considered obvious. So what constitutes prior art, which I mentioned in the previous slide? Has something already been patented? Has it been printed? And this is an important thing for you, especially if you're in an academic institution where research is such a large part of what you're doing. You really need to be cautious about what you print, because once it's in print, even if you present it as a poster, that is prior art against yourself, and you've now made your idea public. and it is no longer eligible for a patent. It is in the public domain. When you do have a novel idea, do not speak to anybody like me until you sign a confidentiality agreement. You want to make sure that anytime you disclose that art, it's with confidentiality, and that is what prevents it from being considered public use. My favorite on this bullet list, and that the Patent Office holds out there, is that anything that is known, and that's a huge thing to overcome. But surprisingly, although somebody back 150 years ago said we can close the Patent Office, there will be no more patents, there's more patents issuing now than ever before. As residents and as physicians, understanding whether or not you own your idea is also important. Whether you collaborated with somebody in the lab, so are you a single inventor? Are there multiple inventors? For there to be multiple inventors, you both have to have contributed to one of the valid claims in your patent. So understand what a contribution is. You can actually invalidate a patent if you fail to list somebody that's an inventor, or if you list somebody that isn't really an inventor and someone challenges that and you review the notebooks and see that that person didn't actually contribute. So you really need to be cautious about giving credit for ownership and understanding who contributed what. Additionally, it's not uncommon, especially in the university setting, that you have an employment contract that requires you to assign all of your intellectual property to your institution. So you may want to investigate that. You may be obligated to work with your tech transfer office. If you are a prolific inventor type person and you really have a lot of ideas, after you finish residency and you start investigating employment opportunities, you may want to make sure that you reserve rights to your own IP as part of your employment contract. So how do you document your ideas? We recommend that you have a bound, not a loose leaf, but a bound notebook. You number your pages, you make your sketches, you put a date, signature, you get a witness or somebody to notarize it. The notary was definitely more important before the first defiling rule, but it's still valuable, and there is still some value in that as potential prior art. So when should you actually talk to industry about your idea? Do you do it early on when you first have that idea, or late? This particular stone extractor came to us from a community urologist in North Carolina, and he had invested about $250,000 of his own money in developing this product. He had his patents, he had engineering files, he had prototypes. He brought us a very comprehensive package that we commercialized on his behalf. On the other hand, the chairman there at UC Irvine in the Department of Urology sketched this idea while he was on an airplane on a cocktail napkin. He went back to his office and put it in his notebook and later called me. But we are also happy to see these ideas on a napkin. Again, though, before you share them with somebody, understand that you need to get that CDA in place, that it's novel, not obvious, and that you have enough of a description to make it work. So once you're at that stage and you're ready to disclose, what are a couple of your options? So what are you going to do? How are you going to get your product onto the market? A really popular model is to say, hey, I'm going to go out and I'm going to find some guys and they're going to give me some money and they're going to make this product. And there was a real big flurry in the biomedical industry in the last decade of venture capital really focused on medical devices. A VC firm, though, really strictly looks at dollars and cents. How much return am I going to get off of this? If this could be a blockbuster, if this idea is a platform versus I'll use a baseball analogy, is it a home run or a single? If it's a home run, they may throw a whole bunch of money at it, but you're going to lose control of that idea. That money comes with a price. If it's a nice double, what they may say to you is, well, we like this. We think we can get you some money, but we need you to invest some of yours first. You get it to this stage, or have your university help you get it to this stage, and then come back to us. If it's a solid single and they really don't think there's going to be any revenue, they're just going to say no. On the other hand, you know, and I'm biased. I work for industry, but I really think that the industry path is a more positive way. I mean, it's a productive, sustainable model as opposed to a cash-driven model. We are equally happy with singles and doubles as we are with home runs. And the nice thing about working and collaborating with industry is when you bring an idea, we're going to look at it. We're going to let you know, does it fit with our product pipeline, with our portfolio? Do we have a business unit that can represent this for you and make a good case? If so, we're going to let you stay involved every step of the way. So through the R&D process, there's communication with you about, you know, hey, we think this needs to be angled at 30 degrees, and is there a clinical reason it needs to be 20 or 40 or 60, or can you put it in some pigs for us? And you have that opportunity to sort of stand side by side with an industry partner and walk it all the way through. As somebody who's designed a device and seen it launch, it's really a rush going from that concept to the first time it's used clinically. It's absolutely a great feeling. So how do you go about choosing an industry partner, right? You're new to this field, you're a resident. I don't know a lot of people in industry. Get on the web, research companies that are active in interventional radiology. Go to the SIR, see who's displaying, walk around the exhibit hall and see who makes products that are in the vein of what you're looking to do. Ask your sales reps. You know, you should have some personal relationships with those. Ask them if their company is interested in what they do. If you want to cold call some of those companies, you should ask for product development or business development, and that'll usually get you to the right person. And this is really the heart of what I'd like to talk about here the next few slides. What should you expect? So if you have an idea and you're going to trust me and industry to develop it for you, what should your expectations be? So obviously there's going to be financial support and dedicated resources to it. But some of the questions you may ask a company is, do you do your own product development engineering, or do you outsource that? Is that your own employee, or are you sending it somewhere else? What's your patent portfolio like? Are you aggressive at filing patents? Do you litigate your patents? Do you defend your patents? Do you only sell in the United States, or do you have global footprint? What countries do you file regulatory clearances in? Maybe it's important to you if your idea is made in the U.S. or if it's made offshore. Ask them, where do you build your products? What type of quality systems do you have? What's your complaint levels like? Right? If this is sort of your child, you want to make sure that you're putting it in the hands of somebody that's going to do a good job for you and a reputable job of promoting your device. If you have a very novel idea and you're changing a paradigm, do they have reimbursement specialists, somebody that's going to go out and help you get a new billing code for this brand new procedure? What's the size of their sales staff? Do they have direct sales, distribution networks? How long does it take? I will tell you right now, from napkin to commercial, today is much slower than it was a decade ago. There's a much larger regulatory burden around the world, and our development cycles are now running about 30 months. Do they have a web presence? What kind of marketing materials do they do? Are they still back in the 60s and making leaflets, or is there interactive video? Are they tweeting? Are they doing SurveyMonkey? All the things that our hosts are doing here tonight. It's important that when you pick up the phone, somebody takes your phone call and gets right back to you, and they're straightforward with you and lets you know what's happening. And then are they going to help you build Generation 2 and Generation 3 of your product if it merits that? And then lastly, you know, what kind of reimbursement should you expect? And before I get to the money, what I would say is that as industry, we have some expectations of you as well. So during the development cycle, we expect you to help us with product design and input, regular feedback, to participate, as I said, perhaps in an animal and clinical work. Similarly, I would expect you to take my phone call and get back to me in a prompt fashion, so that we don't have unnecessary delays. A commitment to filling out paperwork, definitely where it comes to patents and things like that. And then ideally, being involved in studies and presentations and publications. So, money. What do people make when they have ideas? And normally when I'm doing this live, I kind of ask the room if they have any idea what a typical medical device company makes on margin. And it's sort of a dirty little secret, and some of the other people that I work with in industry get mad when I do this, because everybody likes to sort of keep the Oz behind the curtain. But a lot of companies are public. You can look at their financial statements. After the cost of engineering, the cost of sales and everything, a typical medical device company makes about a 30% profit on their products. So when we look at negotiating a deal with somebody who brings in an idea, we're working with about 30% of that pie. Now, up front, Cook at least is not a company that gives somebody $1 million because we love your idea. We will reimburse you. So if you're bringing me the big file and the engineering paperwork and the prototype and the patent, absolutely, if I love your idea, I'm going to buy you out of all that and make you whole and get you back to a zero line. So that is not an unreasonable thing for you to ask if you've gone down that path. But the majority of these deals are based on royalties. Royalties are a percentage of net sales. It's important, if you're negotiating your deal, to understand how a company factors net sales. What do they take out of that before it gets down to the number that you're getting paid on? And there's a couple ways that we do this. It's normally a percentage, and there's some industry averages. But I've also varied from that. If you're uncomfortable with the definition of net sales and you're worried about a percentage of net sales, we've offered somebody a flat fee of like 75 cents per unit or $1 per unit. So there is a possibility of just taking a flat amount on each sale. I will tell you that Cook offers 3% on patented ideas. We tend to pay 1.5% if the product comes to the market prior to the patent issuing. So we'll pay you as though the patent was going to issue, and then when the patent actually does issue, we pay at 3%. You should always negotiate for the life of the patent and expect to get paid as long as there's a patent, and that's about 20 years. And I put this note of other consideration, and there's a lot of things you can negotiate in a deal, but I would say if you're only going to get paid for the life of the patent, you definitely need some development timelines in there and a timeliness to your response, and or an extension of your payments. If somebody doesn't get your product to market for 10 years, you've lost half of your patent life, and you shouldn't just bear that expense all by yourself. Well, that's kind of my thing in a nutshell. I will say that really we are dependent upon you as physicians. I think the symbiotic relationship that exists between physicians and industry is important. We have the manufacturing expertise and the engineering expertise to really make your idea a reality, and I think together we can certainly improve patient outcomes. So thank you for your time.
Thanks a lot. That was excellent. We have good questions. I think we should just go on to Dr. Swan's presentation. So what we'll do, and then we'll save the questions to the end. So let me make you a presenter, Dr. Swan, and then he's going to unmute you.
All right. Can you guys see that screen okay?
Yep.
Okay. So this will come nowhere close to as useful as what Walter was just saying. But you know, this is just from a practical perspective. Like you said, I'm a community radiologist. I'm in New Brunswick, Canada, which is kind of a small province, and I'm in our biggest center in New Brunswick. So we're really a volume-based practice, and just we just cracked through numbers that when I was in Halifax at Dalhousie University would be, we do in one day what we would do there in a week. So a lot of my sort of perspective on innovation comes from an efficiency point of view, because a lot of the things that we do, I figure we can be doing better. And I've always lived with the belief that 100 years from now, we're going to look back at what we're doing currently, and people are going to laugh at the obscurity of the technology that we have now, even though currently it seems so great. So there's nothing that is currently being done that can't be done better, and that's my approach to innovation in general. So keep an open mind. So this is just kind of talking about how to go about taking an idea to the next step. So for us in a clinical practice, I think innovation almost always starts with a problem, and from my experience, it's either something's not being done efficiently, something's not being done as safely as it could be. We have recently we're looking at a procedure in stroke management that could be done, I think, much more effectively, and just coming up with solutions to that. So there are all kinds of people who like to whine about problems, but I think it pays to be a problem solver. And when you whine about it, also try to come up with a solution. So once you've had your big idea, you got to consider a few things. So you got to be pragmatic about the idea itself. Some things are almost, they're common sense, and they're going to be great developments in medical technology, maybe in the distant future. But if the cost of developing something is going to be overwhelmingly expensive compared to its potential applications and how much revenue it's going to bring in, then it may be an idea to keep on the back burner and just wait for your next one. You have to be honest with yourself and honest about your idea. Is it solving a common problem or a rare problem? Is it solving a severe problem or a minor problem? And you have to think about sort of categorically, what is this falling under? Is it are you thinking of a device? And if it's a device, is it a device that's going to be used very rarely but is going to have a big impact? That might be worthwhile. If it's going to be used very rarely but have a small impact, not a lot of people are going to pursue that. So you just have to be honest with yourself, and then be optimistic. As a practitioner, there are a lot of problems that we come across that people outside our field and engineers, for example, wouldn't necessarily understand because they don't have hands-on experience trying to guide a catheter through the small arteries in somebody's brain, and they might not have experience, that geez, the catheter shapes we have are great, but the IVC is too compliant and too big to get good pressure off the back wall in order to engage an adrenal vein. So that they don't know why we need something else. So unless you tell them, they're not going to know. So be optimistic that your ideas are valuable. You have a few options, obviously, and Walter really touched on this a lot more eloquently than I'll be able to. The first option is going it alone. So I've been down all these all these paths. So in terms of going it alone, that's really when your idea doesn't have any current similar solution. So I've started a small company here called Photonics Medical, and we're basically problem-solving equipment and software solutions for MRI problems. And what's happening in the industry is that they don't have anything close to our solution that we can find. So we've decided to patent the project and our idea, and then and there are ways to monetize it. So going it alone in Canada is different than the States, but probably similar everywhere in the sense that universities are interested in helping out. There are always a lot of programs that are accessible in terms of accessing research and development dollars. So even if your idea only matures to a certain phase, you don't necessarily have to take a huge financial hit to explore it. The second option is going to industry right away. I've done that more than anything else, and I'd have to thank Walter and Cook Medical especially for being so receptive to basically this crazy guy from the Maritimes who's sending them an idea every week or two. But there are just certain things that the industry already has developed to such a great point of usefulness that you're just really offering tweaks on something that they already have in existence. So I mean, if I was inventing a new shape for a catheter, there's no way I would bother trying to just patent a catheter shape without checking with industry first. The other thing that happens is a lot of these guys have devices and things that are in development that that you don't know about, but may have a correlate to your idea. So it kiboshes you from spending $250,000 on patenting something and then engineering it and making a prototype, et cetera, and then taking it to a company to find out they already have it. So I've been using, Walter directed me to this Cook portal that is sort of their online way of contacting them about ideas that are similar to what they're doing now, and ideas even in fields that you potentially see them wanting to expand into, but that you don't really, you don't have the energy to go it alone on these things. And that's, I think, Cook has been the most receptive in that sense. Boston Scientific is receptive, but and this may just be personal, but I don't trust them as much as I trust working with Cook, and it may just be that they're a publicly traded company, but that's just personal experience, and maybe I just have stereotyped them in that sense. Anyway, the next option is to get your patent and go to industry after that, and that's something that my partner in photonics, Peter, and I are doing, and with a couple of ideas. And we've actually been lucky in that one of the doctors here in St. John, New Brunswick has ended up being a big innovation guy and a big business guy, and he likes our ideas. So he's sort of giving us some tips and talking us through the process, and also giving us a bit of money to get things done. So in terms of going for a patent, specifically, there are two types of patent that apply in North America. That you can get a provisional patent, and you can expect it to cost $1,500 to $3,000 generally, but it doesn't have all the protection that a regular patent will have, but it still gives you that first to file status. So when you're doing stuff on a low shoestring budget and you're doing your own line drawings, etc., it's not a bad system. The other thing I'd mention is that there are all kinds of companies that can help you get through to your patent phase, and that's really what costs money. But when you look at how much your time is worth from a clinical perspective, you're selling yourself short, I think, to spend 4 or 5 days trying to figure out what patent paperwork you need to do, and basically being your own secretary for $1,500. These companies like IP Mex is the one I use here, and they're based in Toronto, will basically talk you through the entire process. And then the last option is building a company, which I guess is sort of what we're doing with Photonics Medical, but that has a lot of paperwork that goes along with it. So unless your idea is really extremely novel and extremely unique, and hopefully, if you're optimistic about the finances of it, then it may be worth going the corporate route. But I'm kind of going into this saying, well, if we have a company, then it's going to be easier to raise a little bit of capital and research and development dollars and that kind of thing. I'm not expecting to be a billionaire out of any of these ideas. I just personally am very keen on seeing things get developed, and I always try and choose the path of least resistance between the idea and development, because in a sense, this is going to be your legacy that you leave behind for other interventional radiologists. So So, you know, if sometimes going the corporate route is more efficient, but on the other hand, I have a friend, Bob Abraham in Halifax, who's developing these particles that he's patented. I think it's called ABK particles, and you know, he's into the millions of dollars of investment, and he's got his his board of governors and everything else for his company, and that ends up being extremely time consuming. He's taken a year off his clinical work to do it, and now he's going for a second year, and you know, to him maybe that's maybe it's fun, but to me it sounds awfully stressful. So so I wouldn't discourage anybody from going you know, any of the other routes first and getting your feet wet that way. So we just kind of talked about this, but you know, again, being pragmatic, you have to think, do I have time to develop this idea? Do I have the financial stability if this is going to mean I have to take time off work? Can I pay for that? You guys are probably like me, you're all going to come out of school with hundreds of thousands of dollars of debt, and I don't know if you've been watching, but radiology in North America is not exactly a free lunch. You got to work pretty hard for your dollars. So you know, to take time off work in order to develop a device or intellectual property or process, you have to be pretty pragmatic about, can I do this? Do I have the time, and can I get money to do it, to replace what I'm losing from work, and to keep paying my bank so they don't take your house. Then, like Walter said, some people will use their own dollars, and I think most of those people are probably much further down the road than any of us are. I'm 4 years into my career, still paying off student loans, so not to discourage anyone, but it's not always simple to put $250,000 into an idea that you're not 100% sure people are going to want. Then you know, you can explore different types of innovation financing options. So right now, your options are to go to a venture capital firm, or to go to industry, or to get some of this you know, research grants, or get a grant through your university. Everything that you're going to do is going to have a trade-off. You're either giving away equity in your idea, or you're giving away your idea completely in the sense of going to a university. But you know, you always have to make a deal with the devil, and you just got to pick the devil you're most comfortable with. And then, like I was saying earlier, you got to kind of look at what you're making from your clinical work and figure out how much of that can I afford to give up in order to develop an idea, because you know, we know that we've been tested going through medical school, and then residency, and then your fellowship, and you know, you're going to be confident that your ideas are valuable, but to everyone else in the world, you're still an untested entity, because they work in a business world or an engineering world, and you work in a medical world. So you know, if you're looking to replace your typical hourly wage of what you're making clinically, it's extremely unlikely to happen. You do have to give up something if you're giving up your time. So going to industry right away obviously has some huge advantages. Like I was saying, you're potentially, especially if you're really mostly interested in seeing an idea be developed and seeing this as a learning process, but also, you know, starting to develop a device legacy. You know, going to industry is probably your best chance of getting something actually done within 30 months to 3 or 4 years, as opposed to doing it alone, where, you know, you're looking at 5 years potentially. Some of the problems are, you know, you're telling people your ideas, and in theory, you know, if you've already patented it and you're first to patent, and then they stole it, you may be able to have legal recourse if you can find the right lawyer, but a lot of these companies are multi-billion dollar companies, and they have legal budgets that are bigger than your hospital's budget. So you have to keep in mind that you know, going up against them in court is probably not going to yield much success, and is just going to take up more of your time. So if you're really concerned about, you know, the financial side of your of the equation, just make sure that you sign all the right paperwork, your non-disclosure agreements, and all that stuff before talking to them, and keep a record of all your communications. Interestingly, from the photonics medical side of things, not to inspire too much paranoia about industry, because I actually, you know, this is my favorite route to go for almost any idea. But when Peter and I were developing the initial process for photonics medical, and just doing internet searches and sort of talking behind the scenes to players in MRI and some of the other industries that we're involved in, I started getting phone calls from Siemens asking what I was working on, and they don't know me from Adam, so they have ways of you know, sort of finding out who's working on what. So just be, and I'm not saying I don't trust them. I'm sure that they just kind of heard it through the grapevine, but just make sure all your paperwork's in order and that you've kept records of all your communications. Big advantages of going to industry. I mean, I went to Cook Medical with a few ideas early on, and I'm a big software guy, so some of my ideas were more on the software side of things. But you know, they were very welcoming. They took me on a tour of the plant in Indiana. I got to meet with a lot of people in the industry, and all of a sudden you understand where they're coming from a lot better, and it just improves your relationship for the next idea that you present to them. It shows you how to present the idea, and it really shows you how to be more pragmatic about your ideas, and how to better sort of define them into categories like, I want to pursue this right away, or maybe I'll look at this again in the future, because it gives you an idea of how they think about things. And obviously the big advantage is getting your idea realized is probably a lot more likely if you go to industry right away, especially if it's an idea that's in line with their current product line. So it's something that maybe they can alter a process of a device that they're currently making in a fairly cost-effective way, and all of a sudden have something that's going to have more use or better use, or different applications. So we already talked basically about getting your patent first. In Canada, so to get your regular patent, you know, they quote you a price. If you do it through one of these third-party companies and you develop a relationship with them, it's going to be around, for a regular patent, around $20,000 or so. It's generally not too hard to get that much capital once you've had one successful project, or at least a project that's potentially going to employ people. I don't know if it's the same in the States, but here, if you're potentially employing people who are just out of university or keeping people in the province, there are incentives for doing that. So even just hiring people part-time, you can usually get some incentive money. You do have to put some skin in the game typically in order to get money pre-patent. Post-patent, it's a different story. In terms of the industry, you know, it's almost impossible to know whether the industry is going to bite at an idea, especially early on in the game. So, you know, the risk is that you're spending the money and the time to get this patent, and then you'll take it to Walter and he'll say, well, it's not really something that we're into. So, you know, it's always a downside. And then the other possibilities, you can get stuck if you have big financial goals for your patented technology, and you want more than 1 to 3% of a return for sales. You know, you're basically developing that to a late stage product yourself, and then trying to sell it. And again, the further you get along and the more investment you have and the more people you have invested in you, the higher the pressure is on you. But don't let it dissuade you if that's the model you want to pursue. But I wouldn't necessarily recommend going, you know, hoping to hit the home run during your residency or right out of the gate. I would probably, you know, try a few ideas, talk to your local sales reps, talk to people in the medical device industry, and try and get an idea of how the companies are working, where they want to expand, and whether your idea fits their profile and that kind of thing. So one other option that you can do if you're a big idea person is to basically turn yourself or your corporation into an idea incubator, just developing intellectual property and then trying to license it out. And that doesn't really work for devices necessarily, unless you include like taking 1% of their sales or whatever. That's the standard model. But you know, when you're developing software and a software process that goes along with hardware, then really you're developing a process that's patentable and then also licensable, and that can be a potential revenue stream. So we talked about building a company, and we'll just kind of try it. I say down here, don't be afraid to try and don't be afraid to fail. There's this great quote from the book, Shit My Dad Says, and I take it to heart and mind my language, but the guy says, if you try your best and fuck up, then that's okay. But if you just fuck up and then you fuck up, then you're a fuck up. So that's basically my approach to everything. If you try hard and you do everything you can, don't be afraid to fail, because you know that you've tried hard and it's a learning experience. So in the end, advice I'd give to any residents who are thinking of going into this innovation field, definitely pursue it. It's probably the most rewarding part of my career. It's the part that I get most excited about when I think of something that seems like it could potentially be valuable to doctors everywhere. And you know, compared to your day-to-day job, which is, you know, I hate to say it, but after a while your passion turns into, well, this is just my job. When you start thinking about how can I do things differently and how can I do them better, you know, that's when it really gets exciting again. So finish your training, pass your exams. I mean, those are the biggest things, because you want to be safe and have a fallback, and really you want to be good clinicians, and that should be your primary goal right now. You know, like Walter said, keep a book of your ideas, and you don't have to go for everything all at once. You can keep ideas on the back burner. I must have, I don't know, 500 or 600 little ideas that we just kind of sit on and then assess them every once in a while and see if you still believe in it, or if it's a you know, a worthwhile endeavor. Keep an open mind about what you're doing. One big thing is when you see people be successful, try not to be jealous of them, because really, you know, that's a real temptation in our field, because you work so damn hard for every dollar that you're going to make, and then you see somebody sell their company for $100 million or whatever. Sometimes it can be tough not to be jealous, but my biggest mentor now, probably my biggest supporter in terms of innovation, has been Lindsay McCann, who owned a company called Angiotech, and they were one of the first companies to put paclitaxel on stents, based out of British Columbia. And you know, there really is a rising tide theory of success. So if you support each other and you develop a network and develop a system of innovation and a system of mentorship, when you become successful, the people that you're surrounded by also become successful. And the same goes when they have a success, that's also partly your success, and that helps float you too. So you know, whether it's somebody in your area or somebody in your social circle, or however you're affiliated with them, celebrate everybody's success, because it's not an easy thing by any means to come up with a medical idea, come up with a device, and then see it go into application. But that's really something to celebrate, and you know, be proud of each other and help each other out, because it's no man is an island, as they say. So the other plug for innovation here is another company that I'm starting with my dad, called Liftoff Capital. we just got approved for $1 million of venture capital through a VC firm in Boston, and it's in development currently. So we're getting some pretty good feedback on it, and it's basically going to be a way of connecting innovators to investment, and it kind of tears down the current geographic and academic borders that are facing a lot of people in the innovation industry. So if you're, if 10 years from now you're thinking of starting up a company, I'm hoping that you'll list it on Liftoff. It's going to be a cheap and easy way to start fundraising. So anyway, I just want to thank you for your time, and really would like to thank Walter, who's been just a huge support, for so many of my ideas, and his talk tonight was obviously fantastic and very informative, and just thanks for having me along.
Thank you so much. Both talks really filled with really important information for us, especially targeted for residents and medical students and everything. So yeah, thanks again. So I have a couple of questions. I guess we can start with Mr. Ryan there. Just in terms of approaching companies with patents or with ideas, is a provisional patent good enough for that, or do you really want the final patent for that before you either approach a company, or say you want to try to raise some seed funding and do your business plan competition? Is a provisional patent good enough?
Yeah, a provisional patent is great, actually. And we, even in industry, we use provisional patents a lot, especially in the first to file era. It gives you a chance just to get the basics of your idea into the patent office and get that date stamp. The nice thing about a provisional is you can actually refine that idea over the course of the next 12 months before you have to put in your final filing. So you can make improvements to your idea for 12 months. And I'm not an attorney, and I'm not a legal expert. I do a lot of this. There is some negatives because you're in that your filing history trails you, right? So if down the road you end up in litigation over something and there was something in your provisional that you abandoned, or said, this is not a good idea, and then somebody comes really close to your patent and they do it in the way that you crossed out, you're kind of out of luck at that point. So your exam history follows you, but yeah, provisional patent's a great way to go, and it's a lower cost option to get you started. As Dr. Swan said, it's a very useful tool.
Now, what about, say you have a provisional patent and then you're going out looking for some prototyping, funding, and stuff like that, and then a lot of places, a lot of universities or whatever, you have yearly business plan competitions or research grants, so you have to make presentations for those, and you have to sort of give them, some disclosure of what you have, what you're working on, and some of the technical details to a degree. So would that invalidate the patent after you have a provisional, or are you still protected that?
I was having a little bit of a hard time hearing you.
Basically, the question was, if you have a provisional patent and you go out to, say, a business plan competition, or you apply for a research grant for which you have to make a public presentation, or you write something on paper or poster to get those research funds, would that invalidate your patent, or are you still protected after a provisional?
Oh, you're protected once you file a provisional.
I see.
So you're free to start publishing and do whatever you like with it at that point. Once that's in the patent office and has that date stamp on it, you're good. In industry, we still don't really talk about things. It takes a while for a patent to, what they say, publish, or it becomes in the public domain. So even patent applications eventually show up on the USPTO as a published patent application before they issue. And if you haven't written about your idea or presented on it, I would still encourage you to use a confidentiality agreement with somebody until your patent application publishes. So while it's still in the patent office as a provisional or pending, that can still be confidential, but you don't hurt yourself by publishing.
I see. Okay. So if anyone has any questions, feel free to just jump in, or there's a hand raise feature on the side that you can put them in or click, and then we'll be able to see it. I guess the other question I had was if you're affiliated with a university, I've heard it kind of both ways, where some companies prefer that you're independent so that they have ownership of the patent, versus other companies are totally fine with universities being involved as long as they're funding some of the initial patent costs and the initial legal fees and stuff like that. Does that depend from company to company, or is there sort of a general feeling that being involved with the university is a drawback?
So from an industry standpoint, I think it is going to differ some from company to company, but it's also going to differ from university to university. And I have some wonderful university relationships. I just knocked out a contract in like 3 weeks with the University of Akron. I've been working on a contract with the University of California for 3 years. So it really varies greatly. And it can be really difficult. Personally, I've been around long enough that I was ahead of the era where universities really enforced IP ownership on their employees, and I really enjoyed working directly with doctors, and I think that's why we do see a fair amount of our ideas now come from doctors like Dr. Swan, who are in a community practice, and their IP is their own. It isn't a university's. It's much easier for me to work with him as an individual generally than it is for me to have to work with a public institution that is subject to a lot of bureaucracy. But we don't say no to university ideas. I mean, clearly there's a lot of good work happening in universities.
And then Dr. Swan, I guess it's really, really nice to hear a community interventional perspective, just because our only exposure up until this point is academic IRs, just because that's the training pathway and that's the world we're in. So for you, did you start a lot of your? You have over 500 ideas and everything. So I'm assuming you started early, but when you were in residency, sort of what were the things that got your ideas past the first stage of just this is just an idea in my book and taking it forward, and then how do you do it now? Like, are you affiliated with a tech transfer office that helps you through, or how are you sort of funding some of this stuff, and how are you doing it basically when a lot of us get out after residency?
That's a great question. So just so you know, out of the 600 ideas, maybe 50 of them are in the radiology realm. A lot of them are more software related. So, yeah, in terms of pursuing the ideas, like Walter said, as an individual, where I'm just kind of working as a solo entity, companies like Cook have been, extremely generous with their time and feedback, and guys like Walter sort of make the whole process extremely easy in terms of at least getting your idea to the discussion board. I've worked a bit with General Electric on some new technology for their ultrasound B-scan thing. I don't know if you guys have seen their portable ultrasound, but one thing that I will say, I do stay very closely tied to the university circuit here, and I try and stay plugged in terms of any innovation conferences, and even plugged into the basic science side of things. Universities have offices like you guys have a tech transfer office, and I'm not sure what the system is that your tech transfer office works on, but a lot of them, you can either pay a subscription fee. I know like MIT and Stanford, you pay a subscription fee and you can peruse their intellectual property. Because what basically happens is, you know, for us, we look at things from the bottom up. So we'll see a problem and figure out how to solve it. And we may not have the most eloquent solution, but we, you know, that's how we think. We base our work on a problem. In a lot of these big universities, they don't necessarily have a problem, but they often have a very eloquent solution to a problem that they don't know exists. So you, if you stay tied into that, even when you're out in practice, and just stay interested and keep your ear to the ground, you know, there will be services like through Liftoff, we're going to have basically a patent search service, but there are sites now like I think there's one called Patent Duck or something that if you're just interested, you can peruse it. And these guys have patents in all kinds of technology that that they don't realize have enormous biomedical applications. So by partnering with those guys, you can at least try and help them help the industry innovate. It may not be financially that exciting, but you know, if you get excited by seeing an idea realized and by building your biomedical community, that's a great way to sort of come up with ideas. We have a company based in one of the New Brunswick universities here, and they're called ChemGreen, and they basically, this is a good example, they're a couple of professors who are all chemists, and they developed a way of extruding plastic in a cold extrusion process that has incorporated into the polymer antibiotics. And their idea was that we could sell this to ambulance makers and they could coat the inside of the ambulance with this antibiotic plastic. So, well, it just happened that these guys work with another person that I work with in the Liftoff capital realm, and he was telling me about this project, and I said, you know, cold extruded antibiotic impregnated plastic is like the holy grail of polymers for indwelling lines. By the time we'd gotten to them, Cook had already kind of signed on with Spectrum, and they'd gone that route. But these guys, you know, they have solutions to problems they don't know exist. So keep your ear to the ground and you know, be willing to go to some of these boring meetings and keep your ears open.
Great. I mean, I could go on all day, but if anyone has any questions, we can pause for that. If not, I don't want to take up too much of your time. We really do appreciate you coming on and talking to us here, and hopefully we can get you involved in some mentorship over the next few months to the next couple of years. Thanks again, and hopefully we'll see you soon.
Okay, thanks very much, guys.
Have a good night, everyone.
Thank you. Bye-bye.